Hello everyone, myself Subrata Shah. I am the faculty member of Dr. Sudhir Chandra Sur Institute of Technology and Sports Complex. I am a faculty member of Automobile Engineering, and my today's topic is NOx emissions from an IC engine. In previous lecture, we was discussed about the hydrocarbon emissions and carbon monoxide emissions. Now today I am going to discuss on the oxides of nitrogen emissions or NOx emissions. So we know that the hydrocarbon and carbon monoxide both are the harmful and the exhaust gas pollutants, and as well as not only the NOx, not only hydrocarbon and carbon monoxide, NOx is also the major pollutants which is emits from the exhaust gases of an engine. And exhaust gases of an engine can have near about 2000 ppm of oxides of nitrogen, and most of these will be the nitrogen oxides. And with a small amount of nitrogen oxides, there will also be traces of other nitrogen oxygen combinations. They are all grouped together as a NOx, and in the NOx that may be NO, NO2, N2O, whatever. This is the family of oxides of nitrogen, and NOx is very undesirable, and regulation to reduce the NOx emissions is continued to become the more and more significant by year, because we know that the NOx emissions is introduced, NOx reduction is mainly introduced in BS4. That is very important parameter, because in BS1, BS2, BS3 we all know that the main thing is hydrocarbon and carbon monoxide, but in BS4 the pollution control board on the Central Pollution Control Board is totally emphasized on the NOx emission reduction, because it is also the very harmful gases, and that contents of ammonia, NC, so the hydrogen cyanide, so many further constituents may be generated from the NOx. So we have to reduce the NOx significantly, that it cannot be created or generated much more amount which is emitted from the vehicle. And released NOx is react to the atmosphere to form the ozone, and it is also one of the major causes of photochemical smog. You know that large cities like Mumbai, Delhi, especially Delhi, there are so many photochemical smogs are visible at the time of winter season. Okay, so that is also the huge or enormous emission of NOx. And NOx is created mostly from nitrogen in the air. Nitrogen can also be found in fuel blends. Further, fuel may contain the trace amount of ammonia and the hydrogen cyanide, but this would be contribute only to a major degree of source. There are the number of possible reactions that form the oxides of nitrogen also. There are so many reactions there. I have mentioned some reactions, and all the reactions are probably occurring during the combustion process and immediately after, and these include but that are not limited to the NOx formations. Now the NOx formation, we are here you can see some equations like oxygen is reacting with the nitrogen and form the NO and nitrogen, and nitrogen and oxide can generated nitrogen oxide, nitrogen and hydroxide, that may be the generated of nitrogen oxide. So nitrogen oxide in turn can further react to form the nitrogen dioxides also, and by the various means, it including that kind of reaction that you can see, the nitrogen oxide plus H2O may be from the nitrogen dioxide and hydrogen, and nitrogen the oxides of nitrogen is react with the oxygen and it also form the nitrogen dioxide and one oxygen. At the low temperature, atmospheric nitrogen exists as a stable diametric molecules, and therefore only very small trace amount of oxygens of nitrogen are found. However, at very high temperature that occurs in combustion chamber also, and this combustion chamber of an engine also you can say, and some diatomic nitrogen that breaks down to the monoatomic nitrogen also, and you can see the reaction, this diatomic nitrogen breaks down and it creates two monoatomic nitrogens. Okay, from the first reaction you can see that, and it may also that the chemical equilibrium constant of this equation, this nitrogen diatomic nitrogen to the monoatomic nitrogen reaction is highly depend on the temperature. If it is mainly temperature oriented reaction, means if the temperature is vary, then the reaction rate may be also vary according to the change of the temperature. Okay, and the significant amount of nitrogen is generated in the temperature range of 2500 to 3000 Kelvin also. So, and it can exist in an engine. So in this temperature, the diatomic nitrogen is converted into monoatomic nitrogen. So that kind of reaction is possible in the engine, because engine working temperature is near about the 2600 Kelvin. So other gases that are stable at low temperature but become reactive and contribute to the formation of the NOx at high temperature includes oxygen and water vapor. Now you can the breakdown, this oxygen is breakdown to the monoatomic oxygens, and the water is breakdown to hydroxides and hydrogen also. And if one goes a little deep into the combustion chemistry, it can be understood that the chemical reaction of the first one, that the diatomic nitrogen to the monoatomic nitrogen to the breakdown of the water, this reaction much further to the right as high combustion chamber temperature is reached, because that is not happening in the low temperature range. Okay, at higher temperature range, the higher temperature in the combustion chamber or combustion reaction is the more diatomic nitrogen will dissociate to manometric nitrogen, and this nitrogen and the more NOx will be formed at the low temperature. Very little NOx is generated. So this is the reactions which are happening inside the combustion chamber during the NOx formation. So concentration of NOx in the variation of the time. What is the phi? Phi is the equivalence ratio. Okay, and phi is 1 means that equivalence ratio is the stoichiometric ratio, because equivalence ratio is ratio of stoichiometric ratio to the actual air fuel ratio. So if the air fuel ratio or equivalence ratio is exactly 1, that means the fuel are using the stoichiometric air fuel ratio, that is 14.7:1, and the maximum flame temperature will occurs at a stoichiometric air fuel ratio also. So maximum flame temperature, because in the stoichiometric ratios the fuel the air fuel mixture are completely combustion, and it will the totally complete combustion. Okay, no unburned fuel or residual fuels or residual gases are present in the combustion chamber. So that is totally exact combustion needs that demand by an engine. And this graphs also shows that the maximum NOx is formed at a slightly lean equivalence ratio, that is near about the equivalence ratio 0.95. That means fuel are using the lean mixture. Okay, at this condition flame temperature is still very high, and in addition there is an excess of oxygen that can combine with the nitrogen to form the various kind of nitrogen oxides. So if we are using the much more amount of lean mixture, that means the part of the air is increased, so that extra amount of the oxygen or extra amount of oxygen available in the air, that may be causes of the extra oxygen or supply of the extra oxygen that can be generated the NOx emission, or that can be create the NOx emission in the high temperature range near about the 2600 Kelvin, and this is possible in the lean mixture. Okay, in addition to the temperature of the formation of NOx, which is depends on the pressure and also the air fuel ratio, and at this condition, and the flame temperature is, if the flame temperature is the very high, and in addition there is an excess oxygen that can be combined with the nitrogen, that is the cause of excessive NOx productions. Okay, so combustion duration plays a significant or very important role in NOx formation, because if we delay the combustion process or taking too much time and the combustion temperature is too much high, that means the NOx generation is automatically high. And from this figure from this figure, it shows the NOx emissions in x-axis, that is the time, y-axis that is denoted as a concentration of NOx, and x-axis is the denoted as a time. And it supports that the fact of NOx is reduced in the modern engine with the fast burn combustion chambers. So if we design the combustion chamber such a way, or design the combustion process in such a way that the combustion process is too much fast or rapidly, that means the NOx formation is also decreased. And one more thing, that is EGR, that I will tell you later. EGR, the function of exhaust gas recirculation, is also to reduce the peak combustion temperature of an engine so that it can emits less amount of NOx, or the very less amount of NOx can emit from an IC engine. So that is also one process. The amount of NOx generated also depend on the location of the spark plug, where the spark plug where the highest temperature is occurred, because in near about the spark plug region there the temperature is very high, and that's why that is the spark timing. And from the figure or the diagram you can see that how NOx can be correlated with the ignition timing. Okay, so we are denoting the timing as a x-axis, and we are denoting the mole fraction of the NOx in the y-axis. So in this process we are know the factors, that is the phi, and consider how it changes the NOx concentration in the with the spark timing. If the spark is advanced, the cylinder temperature will be increased and more NOx will be created. So more amount of NOx is created, because in CI engine or compressed ignition engine have higher compression ratio and higher temperature and pressure also. So they will divided the combustion chamber, and direct injection tend to generate the higher level of the NOx emissions. Okay, as I told you the EGR earlier, the EGR. Now the EGR, what is EGR? EGR is basically a device which is used to control the NOx emissions, because through the EGR we are using the exhaust gases, and send it back to the engine intake or suction line, that amount of air exhaust gases is introduced with the fresh air fuel mixture, and the amount of exhaust gas in introduction, that is the near about maximum 15 to 20% of exhaust gases we can use as a with the fresh air fuel mixture. So what are the advantage? Advantage is that if we use the exhaust gases or the certain portion of the exhaust gases, that portion of the exhaust gases are not taking places with the combustion. So the volumetric efficiency, that means the is also decreased, and one more thing, the peak combustion temperature is also decreased. So if we decrease the combustion temperature or the peak combustion temperature, as we know that it reduce the NOx emission. So in BS4 to reduce the NOx emissions, some companies are using exhaust gas recirculation, some companies are using the SCR or selective catalytic reduction. Both are used to control the NOx emissions from an engine. So these are the, or one more thing, some companies are using both SCR means selective catalytic reduction as well as the exhaust gas recirculation methods. Okay, thank you. My next topic will be covered on the photochemical smog and the particulate matters. Thank you.